electrical engineer.
I'm Molly Exego and I want to become a mechanical engineer. Gary Mesa and I want to become an aerospace engineer.
I'm Diego Garcia and I want to become an electrical engineer.
I'm Nathan Dork and I want to become an electrical engineer.
And then we have Angelica Gutierrez. She's studying to be a biomedical engineer. We have
Blue tie, computer science. I want to make sure I was.
I'm Danny Trent and I'm biomedical engineering.
Jimmy.
Jimmy Blogger, mechanical engineer.
Julio Navarrete, electrical engineer.
And then we're the dream team.
Yeah.
Okay. So
Okay. So our hypothesis was by increasing thrust, it would increase our distance, and then by incorporating our speed.
My name is Gabriel Castillo. I want to go to the Air Force for aerospace engineering. My name is Manuel Romero. I want to be a mechanical engineer.
My name is Allison and I want to become a mechanical engineer.
My name is Matthew Perez and I want to become computer science.
I'm Cassie Jones. I am an aerospace engineering student.
I'm Mira Miniguez and I'm a mechanical engineer.
I'm Elizabeth Casani and I'm an electrical engineer.
I'm Victoria Serrano and I want to become a PhD. very soon. In electrical engineering.
Alright, so here's how we did. This is our red board, and this is the data collected in a red board, which Izzy will explain. So, okay.
And I'm Drew Gutierrez and I want to be an aerospace engineer.
My name is McKenna and I want to be a computer science.
That's a bomb, and we're also known as turtles and tots. And that's our mascot.
Why is it Raphael? Because we get done.
This is like the angle, like of the arm, and that stops in vision. And I want to be a mechanical engineer.
I'm Julian Navarro, I want to be a mechanical.
I'm Mark Mendoza, and I want to be a civil engineer.
I'm Louis Stroll, I want to be a civil engineer, sustainability.
All right, I'm Matthew Hernandez, and I want to be an aerospace engineer.
Okay, I'm Jocelyn and I'm currently a sophomore studying biomedical engineering.
I'm Alfredo, I'm a senior in aerospace engineering.
I'm Esther and I'm a mechanical engineer.
For the question number 1, what was our lift? Our lift was 0.274 newtons. And for drag, our drag was 0.183 newtons.
And for the way we measured it is by his arm weight. It was
USS Enterprise. This was made in the program that you guys are sitting in front of right now, using tools that I'm going to give you guys right now and a lot of time and patience. So if you guys are really interested in this, I'll teach you what you need to know today so that you can do stuff like this. And if you learn now how to do this, if you're really interested in being an engineer later on, then it'll really come in handy. What is this?
Boba
Fett. All right. All right. This is just a picture. I didn't download the file, but this is one of the MAVs that we're working on in our club. So that's a drone. We're going to put little engines, little motors in these parts, and we'll fly around. So
Research on doing on that track, but
Yeah, I'm mechanical. I'll become a mechanical engineer.
Electrical engineer.
And I'm gonna become an electrical engineer.
Our hypothesis was by increasing thrust, it would increase our distance. By incorporating speed holes, it would decrease drag for the bluebird.
Want to become in the future?
I don't really know yet.
Not sure. You aerospace, and then mechanical. So you're working with two of them. Pick one.
Mechanical.
Ooh, yay, yay. Okay, thank you. Thank you.
I'm Benji, and I want to be a mechanical engineer.
My name is Daniel, and I'm choosing between chemical engineer or mechanical engineer.
My name is McKenna, and I want to be a computer science.
Yeah.
My name is John, I want to be a computer engineer.
Thanks. I'm Bruno. I want to be an aerospace engineer. So far we only have.
My team is a mechanical devils, and my hypothesis is if the bluebird had less blue, it would have flew better. Because the redbird didn't have as much blue as the blue one. And then we figured out that the redbird flew better.
So we got 386.862 centimeters squared. And we
And then we're gonna go to measurement IO, and then NI DAG, and then we go to the DAG assistant. Then we place it here. So it's gonna ask us if we wanna acquire signals or generate signals. So since we wanna acquire the signals through the microphone, we're gonna select here analog input voltage. And then we are gonna select our audio input left, which is what we have connected in here. Audio input.
And where does that connect to the microphone?
Yeah, the microphone is actually connected to the audio input. So we're gonna collect the audio input left and hit finish. And here we have to select all parameters such as the voltage input, and we know that for microphone signals it's gonna be between -2 and 2 volts. And here, instead of having one sample on demand, we're gonna be collecting continuous sample, and we're gonna just leave this as it is and hit OK. And after we create that block, it's gonna ask us, there we go, it's asking us if we want to create this block in a loop. So we hit yes, and then in here we want to send this data to a graph. So in here we're gonna say here create and then graph indicator.
Oh, so that's why you're here. That's why you're here.
And then so there we go, we have the graph indicator.
Awesome.
And
I'm thinking of doing power electronics.
it's So we're gonna say that we wanna read it from -2 to 2.
Yeah, I'm trying to see if I can, I wanna see if I can do.
Okay, and then we are ready to run the application. So we run it,
Something like,
and now we are just
I mean, like, you
gonna.
probably get that, right? They have this one section, so that's in context.
Twist the rubber band.
But apparently it takes
So when we are gonna release it, you're gonna see that the signal increases in the graph indicator. So,
and not necessarily with like the microchip,
Okay,
because
so-
Intel is really known for its micro.
you see it's increasing the
It's
graph
right now,
indicator.
it's working on the new stuff for like Internet of Things. You know what I'm saying? So like incorporating all the things. Yeah, and so I mean that sounds really interesting to me. You know?
That's pretty much it.
Like,
Unfortunately,
so they're trying to figure out, like,
you don't
okay,
see
so
that
they're
the
all
graph
gonna be doing
indicator,
something, like,
this,
what kind of
the voltage
software,
signal increases that
what kind
much.
of processing power do
I mean, we can see
capabilities
the
you wanna put
idea
that
of
on
it.
there?
Once
So,
we are getting it,
I know, I guess for,
then we
I mean, that's the
can
kind of stuff that I would love to do.
we can
If
do
not,
other
like, I
analysis
wanna get into it, like,
with that signal that
something
we're
like-
collecting. Thank you.
free scale.